Great. Okay, we have Arturo next, and we have Jeremy up after that.
Okay. While this boots up, I'll introduce myself. Hello, nice to see you all. My name is Arturo Filasto. I'm the founder and the executive director of and CTO of UNI, the Open Observatory of Network Interference. And we collect probably the largest data set of its kind with respect to internet censorship. That's our goal, basically, to collect evidence of what is blocked, where it's blocked, how it's blocked. So people all around the world can use it as evidence in whatever kind of action they might take. The thing I wanted to talk to you briefly about today is how we're going towards a new way of analyzing UNI data. So the current way, if you've worked with UNI data, and I saw several papers that were making use of UNI data, you've probably noticed that our analysis currently breaks it down into something that's okay, something that's an anomaly, or something that's confirmed block. Confirmed block means we saw a block page, anomaly means we suspect it's blocked, okay means it's most likely okay. Where we want to be going towards is we want to be going towards a model where we're saying more things are blocked, some things are down, and hopefully most things are okay. And in the cases in which it's blocked, we also want to be able to characterize the restriction. So we want to be saying how it's blocked, but also give an expression of confidence, like how confident are we in that statement of something being blocked. So if we see a block page, we might say, well, we're 100% confident. If we don't, then, it's going to be different. And so in this, let's say, journey, I turned to meteorology because I was like, damn, in a way, these people have been working for centuries on this problem, right? Like taking these technical findings and communicating it to a general audience. And surely they must have answers, right? So for example, people are very familiar with weather forecasts. They have a percentage, right? Like you look at a weather forecast that says, 10% chance of rain or 80% chance of rain if you live in England or whatever. I was like, damn, they must have figured this out. And so normally I ask people, but we don't have time, what do you think it means? And this is the formal definition that the US National Weather Service gives for it. But actually, if you go and look at papers that study how even technical people, how much they know about this definition, it turns out that only 26% of experts know the correct definition of probability of precipitation. And so, I don't know, the takeaway here is communicating technical findings to a general audience is actually really hard. So, let's not be too hard on ourselves. Even these people that have been working on this thing for centuries have faced this problem already and are still kind of failing to some extent. But we're gonna try nonetheless. And so we're working on this definition, which we've been calling the likelihood of network interference, or LUNI. So basically how we're saying is what is the likelihood that access to a given resource being restricted via a particular method within the specific network region over some period of time. So it has sort of all these dimensions to it. And then what basically we end up, and if you're from Canada, you will recognize this bird, it's a loon. I could speak hours about it, but I won't because I'm already over time. And so the basic idea is we take these measurements, which are these big packs, we unpack them into observations that then allow us to very quickly iterate on the analysis, so we can then generate these experiment results, which are the things that we then go and deliver to the non-technical data consumers. And this is nice for people like you because we have a data set of these observations, which means that if you want to do analysis on UNI data, you don't have to unpack the measurements yourself. You can use our data pipeline. And so this LUNI basically has these different axes, the target resource, which you can adjust, the location, which you can adjust, the period of time, which you can adjust. And ultimately what you end up having is a kind of probability distribution, if you want, of what is the likelihood of this kind of method given this target resource, this location, and this period of time, what is the likelihood of this kind of form of censorship being present for that resource in that location in this period of time. And yeah, I'm already over time. You can check out the new Uni data pipeline v5 at this GitHub link. You run Docker Compose up and you have it running on your laptop. Check it out, have fun. And if you want to talk more about either loons or data analysis, find me.